Hello everyone. In this video, I'm going to show you the demonstrate the fiction example from the textbook, and this problem going to be a short one. Okay, he say he want to calculate that. Let me check the problem. Okay, so let me turn down some volume. Okay. So what you're trying to ask is, there's a car. Okay, there's a car. And want to make a turn. There's a car making a turn. There is a car here. Okay, and he want to make a turn. Okay, he want to make a turn on two different kind of surface. One is one surface, and one surface is the surface called the friction, the static friction coefficient on one surface is 0.88, and the other is 0.21. You want to calculate what's the maximum velocity to allow this car to make a turn. And the radius of the turn is I think 73 meter, right? 73 meter. Yeah. Okay. So in the previous, maybe from chapter 2 or chapter 3, I said that if you want or last video, I say if you want a car make a turn, you need a centripetal force. Okay, like this picture. You need a centripetal force to allow your car turning. Okay, and so so who provides this centripetal force? It's friction provide this centripetal force. Okay, so friction is important, and especially the static friction. Static friction provide the force, provide the centripetal force. Okay, so he wanted to do, okay, so if you have different surface friction coefficient, so what's the maximum velocity for allow this car to make a turn? So actually, so your centripetal force, let's assume the centripetal force is going to the x direction. So you want to turn in, turning in how to point. Yeah, on the point, I want to turning in, you want to turn it in this direction, x direction, x direction. Okay, and so okay, and the friction provide the centripetal force. Okay, so the friction force is equal to the centripetal force. What's the centripetal force formula? Do you remember that? It's mass times r v squared over r. So this is your turning speed. So what's the friction? Like I said, the friction is proportional to your normal force, and the normal force in the ratio is called static friction coefficient. Okay, so that's a friction. So, and what's our normal force? So let's assume this car, assume no ACC acceleration in y direction. Okay, so the summation Fy is equal to m times Ay is 0. So let's assume the positive is going to upward. So it's your normal force minus your mg, and your weight mass of the car equal to 0. So the normal force is equal to the weight of your car. It's a very simple problem. Okay, so let's put this information in. So the static friction mu s times mg equal to m times r v squared over r, and you can cancel this out. So your speed is okay, nu s times r times g. Okay. So with all the information, we know the radius, we know the gravitation, acceleration of gravitation. So we have all the information. So let's use the 0.88 as the example. So times 73 times 9.8. So what's the answer? Do you have anything to know about that? I don't have answer here. Well, so. Dry surface. Dry is okay. Okay, the answer looks like you'll get a 25. This is 25 meter per second, and you convert it to your everyday velocity. So the velocity we're familiar with is about 90 km per hour. Okay. So and you do a similar calculation, your friction coefficient go down to 0.21. Your velocity, what the textbook says, yeah, it's going to become 44 km per hour. Okay. So that sounds yeah, the result of calculation reasonable. If you have higher friction surface, yeah, it allows you to have a higher corner speed. Okay, 90 kilometer per hour. But you have low friction surface, the maximum speed is only 44 kilometer per hour. So this sounds pretty reasonable. Okay. Okay, so that's a very simple example for the friction, and also the friction help the car turning. The friction provides centripetal force. And a very simple calculation because this on the plane surface, not on the corner. Okay, because not on the bank corner. If this problem is on the bank corner, the problem will become more difficult. So I will demonstrate that example in the next video. So this video I'll stop here. Okay, see you in the next video. Bye bye. Yeah, very short video. Yeah. Only